So we're going to do few problems from exercise 10.1 and 2, which is based on rate. What do you mean by rate? It's like, let's say, 1 kilometer per hour. It is a comparison between two quantities where if one quantity changes, other also changes. If it is 1 kilometer per 1 hour, then it will be 2 kilometer per 2 hours. So this is what a rate. If there is change in the numerator, there will be change in denominator. If change in something like distance, there will be change in time. That's what a rate means. It is given a total of $270 to buy blankets and pillows. I'm just writing B, blankets and pillows. She has a total of $270. She buys 5 blankets per each 12. So what they're saying? One blanket equals to $12 and she buys 5 blankets. So 5 blankets equals to 5 into $12, that equal to $60. Fine. If each pillow costs $15, how many pillows can she buy? So here we have a total of blankets and pillows. We got the cost of blankets, which is 60, which is total blankets 5, and we need pillows. Now pillow, they are saying one pillow equals to $15, but how much money is left? Here Emma has 270. She bought 5 blankets for $60. So what does this mean? So from out of $270, $60 she spent for blankets. This is total, and the left is $210. And now how many pillows can she buy? The left money is $210, which means one pillow is $15. Then if she has $210, how many pillows can she able to buy? That's what the question. By just cross multiplying, we'll get the answer. $15 left. So how many pillows? Let's say X she get. Just cross multiply. One pillow into $210, that equals to $15 into X. So the X value equals to $210 into P divided by $15. Dollar cancel. 15 times 1. 15 times 1, 6 is remaining. It goes to 0, 60. 15 times 4 is 60. So see, 14 pillows she will buy. X equals to 14. P, which means 14 pillows she will buy. And 5 blankets, which is already mentioned. Let's move to question number 7. So here an empty pool can be filled in 5 hours if water is pumped in at 300 gallons an hour. So here you can see this is a question in rate per hour, like this. How many hours it would take to fill the pool if water is pumped at 500 gallons an hour. So how we are going to solve this? What they given to us? They said the pool is filled in 5 hours at 300 gallons per hour. So if it is 5 hours, the pool is filled in 5 hours at 300 gallons per hour. 300 gallons per hour, if that rate it is filling, then what it will be in 5 hours? 1 hour 300 gallons, then 5 hours will be 1500 gallons. You understood? So what I write is, so total water, that equals to 300 into 5, that equals to 1500 gallons. I'll write 300 gallon per hour into 5 hours. So hour out, then 1500 gallons. Done?
So what you did,
I'll just write here, at 500 gallons, per hour, the pool will be filled. The pool will will be filled faster. Why it will be filled faster? Because it is 500 gallons per hour, but here it is 300 gallons per hour, right? And then time to fill. How much time to fill? That equals to total water by new rate. Total water by new rate. That equals to, total water is 1500 gallons per new rate is 500 gallons per hour. So just how to cross out this? So I'll just write things a bit in easier version. So this is the main division format. So it is 1500 gallon per 1 divided by 500 gallon per hour. So this will be 1500 gallon by 1 into 1 hour by 500 gallon. Gallon cut 0 0, another 0, another 0. 5 times 1, 5 times 3. So 3 into 1, which is 3 hour. Question number 11. Henry drives 150 miles at 30 miles per hour. 150 miles at 30 miles per hour. 30 miles per hour. And then another 200 miles at 150 miles per hour. 200 miles in 50 miles per hour. What was his average speed in miles per hour for the entire journey to the nearest 100? This is what we need to find. What is his average speed? This is the question. So average speed equals to, I'll just write AS, average speed equals to total distance
Total distance divided by
by,
total time.
yes, very good. Listen, what is the total distance he traveled? Let's do that separately. Total distance, I'll just write it here. Total distance is 150 miles and 200 miles. So it will be 150 mile plus 200 miles. What is that? So we got total distance. We have to find total time. So for total time first, let's find the 150 miles thing. 150 miles in 30 miles per hour. So we need miles in time, I mean hours. 150 miles, we need it in hours. So what we do, just use this hour by 30 mile. So mile cancel, 0 0 cancel, 3 times 1, 3 times 5. So it's 5 hours. So that will be 5 hours. And we have to add this also, total distance, total time. So what we do, 200 miles in 50 miles per hour. So we have 200 miles, but for 200 miles, how much time it took, how much hour we took? Why I wrote hour? Because it is in hours given. By 50 mile, I just use this information in a reverse way. I can do that. I used in that version. So mile out, 0 0 out, 5 times 1, 5 times 4, that's 4 hour. So 5 hour plus 4 hour. So now I got total distance by total time, which is 350 mile per.
Option A is the answer.
Sorry,
Option A is the answer. We got
350 by 9, you will be getting something like 38 by 8 9 mile per hour, which is option A. So you have to find this time individually and then you just sum up, you'll get the solution. Is that clear? So this is what they'll give, like for rate problem, 30 miles per hour, 50 miles per hour. By watching this, you need to understand this is a rate problem, per hour things. Yeah. At the, coming to 15th question, at the start of dinner service, there were 30 dinners seated inside a restaurant. Start dinner service, 30 dinners seated. The people are having dinner in a restaurant. Initially, there are 30 people are having dinner. They are seated. Now, at 45 minutes into the dinner service, there were 120 dinners seated inside. At 45 minutes into the dinner service, there are 120 dinners seated. If the number of dinners seated inside the restaurant increased at a constant rate after the start of dinner service, how many dinners were seated inside at 24 minutes into dinner service? So what they are saying, if the number of dinners seated inside the restaurant increased at the constant rate after the dinner service, after the start of dinner service, it's going with this rate. What rate it is going? So you need to remove this part, like 120 minus 30 divided by 45. At the start it is 0 minute, but at 45 minute it is this much, which means what rate it is going. 120 minus 30, if you take out, it will be 90 by 45 minute. At the starting, I just calculate the rate by subtracting at 45th minute, and at the starting you can consider 0 minute. If you want, you can subtract 45 minutes, 0 minute. So 90 dinners seated per 45 minutes, which means 45 ones, 45 twos. So 2 dinner seated by per minute. Per minute, 2 dinners are getting in. This is the rate. Hope you understood. For every minute, there is increase of 2 dinner seated after the dinner service started. It started with 30 dinners seated. At 45th minute, 120 dinners seated. It's going with the rate of this. This is the rate we got. That's what they said. If the number of dinners seated inside the restaurant increased at a constant rate, increased at a constant rate for every minute, 2 dinners seated. After the dinner service started, how many dinners were seated at 24 minutes? 24 minutes. How many dinners were seated here? We know that 1 minute, we can do this in 2 ways. We know that 1 minute equals to 2 dinners, then 24 minute equals to how many dinners seated. Or else directly you can do this way. You know that, 24 minutes. You have this question and you want it in dinners. Into dinner service you need. Just write dash dinner. So what you do, the information you know is 24 minutes. You have this minute thing. So write down that 2 dinner by per minute. Minute cancel. It's 48 dinner. Or you just cross multiply this way, method 1 or method whichever you are comfortable. When you are following method 1, minutes on the same side, dinners on the same side. That one you maintain, and then it will be 1 minute into x dinner, that equals to 2 dinner into 24 minute, and x equals to 2 dinner into 24 minute per 1 minute. Minute cancel, x equals to 48 dinner. So this also same answer, this also same answer. So 24 minutes equals to 48 dinner. So what's the answer, mister? Which is the option?
48. Option B.
No. They said how many dinners were seated inside at 24 minutes into the dinner service. You're just calculating at 24th minute. But the question started, but restaurant, this start of dinner service initially directly started with 30 dinners seated inside, and then it at 0th minute there are 30 dinners. You got my point? Which means 30 dinners plus at 24th minute it is increasing. It is at 0 minute it is 30 dinners plus at 24th minute it is 48 dinner. After the initial start, after the start of the dinner service, it's going with a rate of 2 dinner per minute. That's why we are taking this initial one also, then 24th minute, which is 48 dinners extra. So the answer is 30 plus 48, which is 78 dinners, not 48. Jade and Robert accountants who are tasked with reviewing financial reports. It takes Jade 15 hours working at a constant rate to review a report containing 240 pages. So for it takes Jade, for him it will take how many hours? 15 hours working at a constant rate to review reporting 240 pages. For 240 pages, for him it will take 15. Now, if Robert works at twice Jade rates, so Jade's rate, so here you see here, Robert is going to work twice Jade's rate. What does it mean? Robert, that equals to what I can write? Tell me.
You can write how many minutes would it take Robert to review and report
So
containing
here if we cross out 15 times 1, 15 times 1, 15 times 1, 6 is remaining, not 6, 9 is remaining, and then 15 times 6 is 90, so 16 pages per hour it is. So this is Jade. Robert is twice of Jade rate. So that will be twice of 16 paper per hour. That will be 32 paper per hour. So Jade is 16 paper per hour. Robert is 32 paper per hour. Now how many minutes would it take Robert to review a report containing 120 pages of financial statements? So what do we have to do, mister?
Now we need to.
How many minutes would it take? How many minutes would it take to review 120 pages of financial statement? For whom they are asking for how many minutes would it take Robert? It's talking about Robert. So Robert information we have here already. For 120 pages, how many minutes it take? So we have some information here. What we take here, it is in hour. We just want to cross out this P thing. So 32P here, and then hour. So PP cross out, and then we need to cross out minute, but we need to cross out hour. We need in minute. So 1 hour equal to 60 minute. So I cross out hour. So I ended up with minute. 120 into 1 by 32 into 60 minute. So by solving this, we are going to get the final answer. Can you just do the multiplication, this calculation part, and let me know what's the answer, mister?
Okay. 225.
Yeah. So that's 220
225 is the answer.
minutes. So just 120 multiply by
225.
60, that divide by 32, which is 225. So option A is correct. 19. During a race on a circular racetrack, a race car burns fuel at a constant rate. After lap 4, lap means one circle like this. After lap 4, the race car has 22 gallons, left 22 gallons, and then in its tank. After lap 7, the race car has 18 gallons left. After lap 7, left 18 gallons. After lap 7, 18 gallons. After lap 4, 22 gallons. Fine. Assuming the race car does not refuel, after which lap the race car have 6 gallons left in its tank. After which lap? After dash X lap, there will be left 6 gallons. This is the question. Here they said one more thing, it's a constant rate. You need to understand this is a rate problem. And after dash rate, 6 gallons left. How to find out this? So you can see here, they are going with a constant rate. So what is the difference between these two? Lap 7 minus lap 4, lap 7 minus lap 4, that equals to, why I'm taking that difference? That gives what rate it's going with a constant rate, but what rate? If we take the difference of that, we will get the rate of it. So it is 22 gallons left minus 18 gallons. I'm just taking the difference, nothing. Lap 7 minus lap 4, which is for every 3 laps, there is 4 gallons it's consuming. It's getting decreased. You need to understand, laps increases, gallons decreases. If you move ahead, what happens? The fuel in the tank decreases, right? So it is actually 22 at lap 4. When the lap increased to lap 7, it did 3 more laps, then fuel decreased. You understood?
Yes.
You can go like this only and you can find out, like lap 7. We need to till 6 laps. We know the rate now. We can just randomly think and say lap 7 equals to 18 gallons. If it is lap 10, for every 3 laps, 4 gallons decreasing. Lap 10, 14 gallons. Lap 13, it will be 10 gallon. Lap 16, it will be 6 gallons.
6 gallons.
Think and you can get it, but that is not the fastest way to get it. But what is the other method we can do it? We understood that for every 3 lap, 4 gallons it's taking. For every 3 lap, 4 gallons is consuming. So what we need when it will be 6 gallons, like when at what lap we get 6 gallons. So actually how much we have? 18 gallons at this one. We have, you can see this point, 18 gallons minus 6 gallons, that equals to 12 gallons. You got my point? We need to be left with 6 gallons. So I'm just removing, we are at 18th gallon. From 18th gallon, I'm removing 6 gallons. So 12 gallons is the difference. So this 12 gallons difference, what I'm going to do is 12 gallons, I need it in laps. So 12 gallons difference, what we have here? This is nothing but 3 laps per 4 gallons. So I'll write 3 laps per 4 gallons. So gallon cut, 4 times 1, 4 times 3, that will be 9 laps. This is not the final answer. We are at what point? We are at, where is this? We are at this one. Lap 7, 18 gallons. lap 7, 18 gallons. So what we do is plus 9 laps plus laps 9, that equals to 16th gallon we will get that. So that will be 16 laps, we get 6 gallons. I just added this two. Is that clear? Okay.
Hmm. Yes, yes.
So 12th question, the ratio of milk to flour in a mixture is 16 to 10. Milk to flour, this is not rate problem. Milk to flour. From here you need to understand it's a 2. It's a ratio problem. That is 16 by 20. If 10 cups of milk are added to mixture, how many cups of flour must be added to the mixture to maintain this ratio? They are saying if 10 cups of milk are added, milk only, flour, milk by flour. So now how many cups of flour must be added to the mixture to maintain same ratio? Just equate them. Same the way how we solved yesterday. We have to do it in the same way. Just equate them. They given one ratio and they said other value of the same ratio quantity is increased with some 10 or decreased whatever it is. To get the unknown value, just equate them. 16 by 20, that equals to 10 by x. So x equals to 10 into 20 by 16. I just completely forward this to right side, and
Yeah.
that will be 2 times 8, or else, yeah, 2 times, let's do with 4, which better. 4
Hmm.
times 4, 4 times 5, 2 times 2, 2 times 5, that is 25 by 2, that x equals to 12.5 or 25 by 2. To maintain the ratio, floor will be 12.5.